I have been developing my own engine, and in this video, you'll see how its map editor was created and the technical decisions behind it. Keep in mind that this is not a tutorial, but I'll try to cover most of the process. We'll create a new project for the editor, set up the resources necessary for drawing the map grid, then export and save the map into the database using our admin API, and finally load this map in the client. First of all, why am I creating a new engine instead of using an existing one? First, I want to improve myself, and second, the engine I am creating is based on two existing ones, Elysian Engine and Eclipse Origins, both developed in Visual Basic 6, and they're quite outdated by now. So my mission is to recreate the main features of those engines using C#, the monogame library, and the relational database. One of the main features is the map editor. So, how did I start? At first, I was creating the map structure manually, directly in code, which quickly became painful. So, I decided to build a separate project, the engine editor. Installed the main libraries, monogame and Gun. Gun is an open source UI layout tool with a powerful UI editor, and it's an active project, so it really helps save time. Added the resource panel, the place where tile sets are displayed and can be selected. Created the drawMapGrid function in the graphic class, which is basically a copy of how the map is rendered for the client, but with grid lines to help the developer. But in order to understand how drawMapGrid works, we have to understand the map structure. We have many maps, and each map has many layers. Each layer belongs to one map, a one-to-many relationship, and each layer has many tiles, a man-to-man relationship. Added the scroll bars and adjusted drawMapGrid to take the viewport into account. And the most important thing for an editor, the ability to edit. You can click on a tileset, a selection box will appear, and when you click on the map, the tile in that position receives the selected tileset's properties. Now we have to save it, right? Yes. So let's move to the server side. First, I needed to install the .NET library for using web APIs. I already had TCP and UDP configured. But why use a web REST API instead of the existing TCP UDP sockets? Well, those socket protocols are already being used by the client for regular tasks. TCP is used to receive the map and inventory, UDP for movement and combat, and saving the entire map with all its objects and relationships would be too heavy for sockets, but not for HTTP. HTTP supports large payloads, and right now a map with 2 or 3 layers is around 30 kilobytes. Now it's time to create the controller. I added a special annotation to the method, the protobuf annotation. Why? Because protobuf is an alternative to JSON, and for us is the right choice. It helps serialize the entire object, and if both the client and server are aligned on the object model, the data will be compressed and transmitted with no loss. Now, the controller calls a service, which saves or updates the map, layers, and tiles in the database. Back in the editor, we need a button to provide the Save Map functionality. So, now, when I click it, the map editor service is called. It serializes the edited map using protobuf, calls the API, and if everything goes well, the map is saved into the database. However, every time we close and re-open the editor, it starts at map 0, the first one, with an empty X structure, and that's not what we want. So, we need to create a getMap endpoint in your API, which will do the inverse process. It fetches the map from the database and sends it to the editor. In the editor, we consume it so that every time the developer changes the selected map, getMap is called and fills the map's collection in the correct index. Now, look at this. We have another problem. We only have one tile set, and that's not very useful. We need to add support for multiple tile sets. So let's update that. Finally, the last improvement I want to include before releasing the first version of the map editor is event tiles. Tiles that can trigger some kind of event like healing, teleporting the player, or the one we will implement, the block event, to prevent the player from accessing that tile. And of course, we'll need some visual indicator for these tiles. That's it for now. In the future, I plan to refactor everything and add the missing functionalities, like other tile events for example. I'm also thinking about adding commands to the map editor, Ctrl-Z, selecting multiple tile sets at the same time, and so on. I will probably make another video showing the implementation of those commands using the command design pattern. In conclusion, I'll leave you with the first map ever created in your editor, running inside your engine.